In the last video, we talked about where the natural log function comes from and what it is. In this video, we want to look at just derivatives and integrals related to it. So we know the natural log function is defined to be this definite integral. That means that its derivative, according to the fundamental theorem of calculus, right, derivatives and integrals undo each other in a sense. Okay, they're sort of inverses. Okay, so that means the derivative of natural log is going to get me back to the function I started with, that 1 over x. All right. And the integral 1 over x dx, you may remember the formula from Calculus 1, is natural log absolute value of x plus c. Okay, that absolute value, hopefully your Calculus 1 teacher explains where it comes from. It's kind of cool, but we're just going to use it, okay, today. All right, so let's practice. So the best way to go through this practice would be for you to pause the video, try the problems yourself, then watch me work them, but that is up to you. So this first one, I have a function inside a function. So that means I'm going to need chain rule. Right, my inside function is x squared plus 3. My outside function is natural log. So chain rule says when I take the derivative, I take the derivative of the outside function, keeping the inside the same. So my outside function's rule is that I get 1 over the argument. So I'm going to get 1 over x squared plus 3. Then chain rule says multiply by derivative of the inside. Well, the inside's derivative is 2x. So final answer for this derivative is 2x over x squared plus 3. It's possible you were able to jump straight to that final answer. If so, that's great. Okay, that's where you want to be for Calculus 2. You want to be able to write these quicker. It'll save you so much time and effort. All right, let's look at the next one. So if we do this like we did the previous one, I have an inside function and an outside function. Inside is t to the 4th, outside is natural log. So natural log's rule is to take 1 over the inside. Then, according to chain rule, derivative of the inside needs to be multiplied at the end, so I get 4t cubed. Do some algebra and simplify that, you will get 4 over t. But that's actually not the only way I could have solved this. You may have figured this out if you paused it. You can use those properties we mentioned in the last video to make this easier. So I could have rewritten that function before taking the derivative as 4 times the natural log of t, because that's my power rule, my property for powers in natural log. So constant multiples hang out when you do derivatives. So I get 4 times the derivative of natural log of t, which is 1 over t. Or you could write 4 over t, same thing. So either way, derivative is 4 over t. All right, let's look at some examples of integrals. At this point, really our only method is substitution. So let's try that. So I look at this first one and I think, that denominator looks kind of messy. So maybe I could replace that denominator with u and something nice will happen. So I'm going to let u be w squared plus w plus 4. Now hopefully this gives me a nice du to work with. Let's see. Well, that makes du 2w plus 1 dw. I look back up at my integral, say, wait, I do have a 2w plus 1 and a dw. So those multiplied together are exactly the same as du, so I can replace them with du. So I picked a good u because now my integral is going to become nice. So with substitution, replace each thing with what it's equal to. Okay, so the denominator is equal to u, so it gets replaced with that. 2w plus 1 and dw multiplied together are equal to du. So I have nothing left in the numerator, so I have 1, because that's my multiplicative inverse. All right, now this rewritten integral, this matches my natural log formula perfectly, so I'm good to go. I get natural log absolute value of u plus c. Plug back in for u. And that's our final answer on that one. Natural log of w squared plus w plus 4 plus c. All right, next one. So again, our only technique at this point, substitution. So let's try to find a u. So I have 2 possible choices for u. So let's write them both down and see which one gives me a nicer du, a more useful du. All right, so if I let u be natural log of z, du is going to be 1 over z dz. That looks pretty nice with the integral I have. What about this other u? If u is 1 over z, that's really, I'm thinking in my head, that's a z to the negative 1 power. So his derivative is going to be a negative 1 z to the negative 2 dz. I do not see any z to the negative 2 or z squareds in that original integral, so that one isn't useful. We want to use the first one. That one has nice pieces. So I look and say, well, I need a 1 over z and a dz to create du. I have a 1 over z and a dz. So those together are going to create du. And that natural log is exactly equal to u, so I can replace him with u. So here we go. All right. So that natural log is in the numerator, so my u is in the numerator. The 1 over z and the dz get used to create du. And I have nothing left in the denominator, so secretly it's a 1, right? So really I'm just looking at the integral of u du, which is basically the very first type antiderivatives you had to do in Calculus 1. Okay, reverse power rule gives me u squared over 2. Plug back in for u. We get natural log of z squared over 2. Some books will write this as ln squared z over 2 plus c, same thing. So either of those final ones is a perfectly valid answer. Okay, perfectly valid way of writing this answer. So that is the review of derivatives and integrals with the natural log function. And the last video in this series is going to look at all things exponential function that you need to know for Cal 2.